Today, 4.6 billion years after the solar system's birth, the ongoing, if remote, danger of a massive asteroid strike means the story is not over. More important, though, are the hundreds of tiny asteroids hitting the planet as meteorites. Studying them tells us if the making of the solar system really happened when and how we think it did.
I'm holding a sample of the Allende meteorite. The Allende meteorite is a fragment of rock that fell in Mexico near the village of Allende in 1969. One of the components of the meteorite are these calcium aluminum rich inclusions, these white objects that you can see on the surface. These are the oldest known materials in the solar system, and we know this by age dating with radiogenic isotopes.
In his high-tech lab at UCLA, cosmochemist Ed Young and his colleagues carefully examine tiny samples of ancient meteorites.
There's a big white fragment in the middle, which we want to cut out.
The lab's precision lasers aim at the fragments, blasting out holes no wider than a human hair. Sophisticated analysis measures radioactive elements, which serve as atomic clocks. In early 2011, cosmochemists in a similar lab at Arizona State University dated part of a North African meteorite to an incredibly accurate 4.5682 billion years old, the oldest material ever found on Earth, older than the planet itself. In August 2011, the Dawn spacecraft arrived in the asteroid belt, source of most meteorites. Close-up pictures of Vesta, the second largest asteroid, open a new epoch in telling the solar system's story.
One of the exciting things about the Dawn mission is that we're going to get our first glimpse into something that was essentially a mini planet that was formed right at the beginning of the solar system.
Since its birth early in the solar system's history, Vesta has been undisturbed by weather or many of the geologic forces that have changed the planets over time.
Just like some of the larger planets, it has volcanoes, it has a core, but unlike these larger planets, not much else has happened to it in the past 4.5 billion years. So we essentially get a window back into that very earliest history of the solar system.
Dawn will orbit Vesta for a year before going on to spend another year orbiting the largest asteroid, Ceres. Meanwhile, NASA's Juno probe has just begun its voyage to Jupiter, where it will visit the giant planet to determine if it really does have a solid core and formed early and quickly, as scientists now believe. Even more crucial are other stars with their own solar systems whose formation sheds essential light on our own.
The most important reason for understanding how the solar system was made was to find out whether or not we're normal. When you look out and look at other solar systems being made with our telescopes today, for example, in Orion and other places, we want to answer the question, how normal is the solar system?
Launched in 2009, the Kepler mission is now running full blast and has identified 1,200 possible planets around other stars. Some systems have Jupiter-sized planets close to their suns or in lopsided orbits. Others have only small planets crowded closely in the hot zone of their stars. Our solar system, however, has its planets in near circular orbits, spread out in a stable arrangement that seems almost too perfect.
One of the great surprises of the last decade, as we started to discover other planetary systems, was the fact that our solar system seems to be one of the oddballs, mostly because our own solar system is so regular.
Is the solar system made by processes that we can observe going on today, or are we somehow special? This goes to the point of whether or not life is special.
And that question is perhaps the most important one of all.